Yes, like this. So this is instruction 13, the last instruction in the BPI course, and is based on the material seen in lecture 16, part of the material seen in lecture 16, which is about refined process mining and prediction. And that is a lecture which gives an overview of a lot of different topics, a lot of different ideas in process mining, many of which are of a very, very recent development. So for this instruction, I will start by saying that if you should be able also to see my screen here as I switched to the browser, and the BPI course, you can access the lecture of the BPA course on the Moodle, but the BPA course is also available on YouTube publicly on VL's channel. And there is a playlist with all the lectures of the BPI course. And I will now copy the link in the chat. Where's the chat? There. So you also have the chance to access the lectures whenever you want on YouTube. You can share them. Anyone can attend the lectures essentially, and you're not limited by accessing Moodle. Right. This is very important. Okay. Back to the instruction, and today we're going to talk about prediction, which is usually considered a part of operational support in process mining. So operational support is a discipline, a part of process mining that guides decision through the process. Usually, that is the primary focus of operational support. And in this case, we're looking at prediction. So this is an important part nowadays of process mining. It's just the main point of contact between process mining and other data sciences, such as machine learning. And it's a focus of very intense research lately. And to see operational support in the form of prediction, we are going to use the sepsis cases event log that you can find and download on Moodle, so you can follow the steps with me. This instruction will be fully on ProM. We will look at a prediction plugin. Note that the plugin and the prediction approach we're going to see is based on decision trees. So it is a prediction approach that is transparent. It is white box. It's extremely clear what it does. It's something that all of you know from not just this course, but also other courses, other lectures you attended. That is, of course, not the only operational support method, not even the only prediction method in process mining. As a general remark, of course, lately in process mining, what people tend to do is to apply novel prediction models like neural networks, specifically recurrent neural networks and LSTMs and other such methods. Also, there are also approaches with generative methods now. We're seeing very recent research in explainable predictions in process mining using neural networks. The reason for that is, of course, the same reason why deep learning has taken the role that before was covered by approaches as shallow nets, LSTMs, Bayesian learning, and so on, because it's much more accurate. You can manage, deep networks can manage complexity of data, of highly dimensional data, and still give an accurate result, provided they have enough data. And there are such approaches for process mining. We're not going to see them today for a number of reasons. The first reason is that they are not, there's not much to see visually in an LSTM. You can get the the stats at the end, but visually there's not much to see. That is the first reason. The second reason is that these approaches are usually implemented and shared by the researchers in Python, and so using as a support libraries as PM4Py, but these are usually, yeah, it's coded programmatically, and it often doesn't have a visual interface, so it's much better to look at something in ProM, something interpretable, something that you can see. But at the same time, you should be aware that deep learning approaches, specifically like recurrent LSTM approaches, work very well on process data. And the reason for that is that they are very suited to manage data in the shape of sequences in a non-fixed length. And in fact, LSTMs have had a lot of success with text, right? With free text in NLP, in text mining, LSTM have been used a lot. And that translated immediately to a very high accuracy and applicability in process mining. Yeah. So if you look at recent research, you will see a lot of recurrent neural networks. But today we're going to see what decision trees can do for us in process mining. So the plugin we're going to see is perform predictions of business process features in ProM, which has, and you have it on the slides, it has both a manual of use that you can take a look at to see all the functions, but also has a paper associated, which conversely shows, let's say, the concept behind the plugin and the experiments and what it can do in a more scientific way, let's say. And you can also access the paper in the link you have in the slides. We'll see the plugin here in the instruction. So prediction of features of processes can take many forms. And we have a number of possible targets for our prediction. So prediction in general means that we are either performing classification or regression. So we are guessing either a class of something, of some target attribute, or the value of a numeric target attribute. So in process mining, what people tend to do is that they look at specific perspectives and specific targets. So historically, elapsed time and remaining time have been the most, let's say, popular targets for work in prediction and process mining. Elapsed time, you also find it in literature as completion time or sometimes cycle time. These three things all refer to the same target, which is the total duration of a case, right? So the total time duration of a case, that's what we mean here with elapsed time. Remaining time, conversely, is the interval of time between the last event observed in a partial trace and the final event in that same instance. So we are estimating the time that it takes from the point we are now to the completion of the case. These are very similar concepts, and in fact, of course, you can get to elapsed time with remaining time by summing the time that passed until now, but are considered separate because technically, if you when building your table for the training set for your machine learning prediction approach, you have to decide which of these two is actually the target, but it's easy to go from one to the other. And then, yes, activity duration. We are now performing an activity. I want to predict when that will end. For logs without the start and complete, we touched very briefly on this yesterday. Logs without the start and complete, this is equal to predicting the timestamp of the next event, right? Because that's when the complete of the current activity will occur. So these are the possible targets for the time perspective. For the resource perspective, we can predict also here a number of features that we can extract from a log and use in the training as targets for the training of your prediction model. And we can predict the executor, for example, of the next activity, so the resource that will be assigned to the next activity. If we have a definition of roles in a process, we can, in principle, train a classifier on known roles on the existing resources in a process and use that classifier to predict a role for a new resource. That's also something we can do. And there is, of course, resource workload. So I can predict how many activities a specific resource will be doing at a time. This is for cases where in the log I have both the start and complete lifecycle authorization available for my event data and also the resource information, right? I need both for this one. And there are other examples. And for the control flow perspective, also something that we're going to see today, I can predict the label of the next activity. So rather than the time, here I want to predict what activity is going to be executed next for a specific case, which is running right now. And this has more control flow flavor, as you know, because that's the, let's say, the sequence of activities that is executed for a specific case. What we're going to look at today is elapsed time and next activity. So these two examples for the decision trees. But you will see now that using the plugin, it is very easy to extend what we're going to see today to other of the targets that you see on the slides, but also other completely different things. In general, you can just, if you have one attribute, for example, an event attribute in your log, you can predict the value of that. So if I have an attribute cost in my event log associated with every event, I can aim to predict that for the next event, for example. And that is possible for any attribute. So things are very flexible. But this slide just summarizes the most interesting things that people usually look at. One that is not mentioned here, but that now comes to my mind. And there have been quite a lot of work on that, is SLA violation prediction. So this has also been used in companies. So this is the case where, let's say, the company A sells some software to company B. And as you know, nowadays, the business is not very much in selling software or selling licenses, but it is on selling assistance and the installation and the help desk service. So companies A and B in this example strike a contract, and the company A, which sold the maintenance and assistance for the software, has to, let's say, solve the problems that company B might have in a specific time frame and under specific conditions. So companies that sell software usually have different levels of service, with each with an associated cost. But if the company that provides the service does not make it in time, does not solve a problem in time, they have a fine to pay, or there are some consequences. And these are called service level violation. There are quite a few papers on predicting for which cases the service level agreement will be violated. So which cases will take more time than specified in the service level agreement. And in principle, this is binary classification, because it either is not violated or it is. But it is very prominent in literature. Of course, it is very connected with elapsed time and remaining time, because these violations are based on times usually. And this is a further example that I wanted to to tell you. So let's look at exercise one. So the log is the subsys one. Exercise one asks us to construct a decision tree to predict the elapsed time of the cases using the following information. So we need to use all the attributes as a predictor variables, and we need to use as a technique for discretization of elapsed time binning, which with 10 equal with bins. Okay, so let's try to do this. We can open ProM. You should see my ProM screen now. Let me move. Yeah, and let's import the event log, which is this one, with any importer. Right. So from here we can go on the plugin selector here, and if we type prediction. Yeah, so this is the plugin that we are interested in by Professor Massimiliano De Leoni. And we can start the plugin. And if we start it, we see nothing, but that's normal. Don't be scared. Now it says impossible to build a decision tree if no output feature is chosen, because we need to set it up before we see the tree. So here we have a list of activities, but we need to make sure that all are included, but by default, it includes all activities. Now, if you go on the right-hand side, you see two tabs, and the tab attributes allows you to select the attributes for the prediction. And we want, from the data perspective attributes, we are going to select all of these, right? And but we need one more. We need our target, and our target will be the elapsed time from the time perspective. This is specified that it is in milliseconds. And once we selected this, we can create the augmented event log. So what that means essentially is that it extracts from the event log a training set from for the decision tree, right? And that essentially is a table. So if I click there, and I let ProM crunch the numbers. Okay. We can see quite a lot of stuff. Let's see what the attributes say here. So let's configure our tree. So dependent characteristic up here is what we want to predict. I just gave it a set of attributes. Of course, I need to tell the decision tree what the target is. And here, target is elapsed time. Right. You can select elapsed time and update the decision tree, and you should see a different tree. Right. Yeah, looks way better. So this is the decision tree that we get with these settings. One more thing that we need to check is that so the exercise asked us to use 10 equal with bins, and that is what we have here. So this the third tab here that appears when you create a tree, actually when you create specific trees, and these trees are all the trees that have a numeric, the decision trees that have a numeric target, and I will see why. You get this discretization tab because, of course, if you are building a decision tree for classification, but you want to use a numeric attribute as a target, you need a conversion, right? Because you can't classify a continuous numerical attribute, but you need to convert it into a classification problem. And one technique to do this, but you have seen this, and this is just a recap or reminder. One technique to do this is binning. So binning is a very simple approach where the idea is that we take all the possible interval, the domain of value for the target variable, and we split it into sections that we call bins. And what we actually predict is in which bin we end up with a specific classification, which in case of decision trees is a path on the tree, right? So that turns the regression problem in a classification one, and gives you every bin becomes a class in your classification problem. And here we select 10 bins with equal width. So this interval, this domain for the elapsed time is split in equal parts, right? And this is the result that we can see. And you're very familiar with decision trees. The way you use a decision tree, assuming that you have, so now here, what we did was using the entire historical log to build this decision tree. What you can do is that if you have new partial instances coming in, you can follow the decision tree and establish a bin. So the value of the target attribute for the elapsed time of that partial instance by following the value for the attributes that you can see here. Right. This is how you build a decision tree, and we did it with the settings that the exercise asked us. So let's look at part 2, or part B, rather, of exercise 1. So this asks us to build a decision tree to predict the elapsed time of cases with the following information, also all the predictor variables as before. But this time I want, as discretization, I want 2 equal frequency bins. Okay, so let's do that. We need to, so the setting remains the same for the attributes and also the configuration. Now I'll notice something. You have various settings here, but for this tree, there is some pruning applied. So what's that? You know that the decision tree you have to decide where to stop when splitting, because you need to, the more and more you split going down your tree, the more specific your model will be. But of course, you don't want to do this to the end, because that model will overfit your data quite a lot, meaning that it will not generalize well to unseen instances. So you want a trade-off between a very short tree and a very long one. And here there is some pruning applied with the settings that we have here. So this slider here, the first slider, allows you to control the threshold for pruning. So this is also something that we have here. Going back to the second part of the exercise, if I open the discretization tab, I can select 2 bins with equal frequency. Now, what changes here is that the bins are not spaced with an equal width on the interval of the target, but they are split based on the number of instances that fall in that bin. And here we are trying to have equal frequency bins, right? And what this does is usually this leads to a better prediction in terms of balance among the classes, because this means that we are purposefully building a training set which has the same number of training examples for each target class in the target attribute, in the dependent attribute, meaning that in theory, the tree will be very balanced because for each possible class, I observe the same number of example, and usually that's what you want when you are trying to build a model that actually performs well. So we can update the decision tree. No, not with this button, but before that, we need to change the intervals with this button here, and this works out the new binning. Takes some time. Okay, so we have a result, but maybe we are interested in something that is not that looks more like a tree and less like modern art. So we go into configuration, and what we can do to visualize this tree a little bit better is that we can. So there are two visualizations possible. And we are currently looking at the helicopter visualization. You can see that the tree looks like a helicopter here, yeah, as you can see. But we can select the explorative visualization, which is a little bit more dynamic. And if we update, we see this very nice animation of the tree. And we can actually follow the path of an instance in the tree. So it gives us the first split. So if this attribute here is true, we go to lactic acid. And if I click there, it expands the following choice. Let's say that the following choice is this. And then we get to a level of the tree where you have a bin or a target down here. All these values are a bit wacky because it's in milliseconds, right? So 1.425 times 10 to the 7th, that's because it's in milliseconds. There's also a trade-off between readability and precision of the unit of measure here. And you can expand the tree however you want. On diagnose, it takes a lot of choices, as you can see. So this is how we do the B part of this exercise. Okay, then now it asks us to build a decision tree to predict also the elapsed time using the following information. This time we're going to use just age as a predictor variable, and we're going to discretize with 2 bins of equal frequency. So let's do that. This time I need to let's switch back to the helicopter one, and I need to select just age. Right. So, oh, okay. Just age and elapsed time. I can create the augmented event log. Let's check if all the other settings are correct. 2 bins, equal frequency, and the configuration we have the same as before. Let's keep this one. So now you have a tree that predicts the elapsed time in the process just by looking at one attribute, and you can see that this algorithm can split on one feature, one column of your data set, which is here the augmented event log, multiple times to get you to the correct bin, or to a hopefully correct bin. Something that I can show you here on this example is that there is a small summary tab here at the bottom. And if you open it, you get a summary of stats in regard to the decision tree, and you have all the usual stats based on the decision tree and the training set that you get that you know from data science and other disciplines, other courses also that you attended or other teaching. And you have the usual measures are all here. These are all, let's say, straightforward for people that know a little bit of statistics, a little bit of machine learning, a little bit of decision trees, etc. You get all the stats here. Now, let's look at the following part. Part D asks us to construct a decision tree to predict the elapsed time of cases with the following information. So we are predicting the elapsed time once again. I want all diagnostics fields, and the discretization is the same. So here, let us select the diagnostics attributes. So I'm going to deselect age and select the diagnostics, which are these ones. And yeah, that's time. One thing here, so how it works is that when you select the attributes, the last one you select becomes the default target attribute or dependent attribute afterwards when it builds a tree, when you click this button here. So elapsed time will become our target because it takes it as default. But you need to always check if the your target attribute is actually the correct one. And if you want the second tab, elapsed time in milliseconds, that is what we want, right? So here we have, let's check also the other settings. 2 pins, equal frequency, this works. And this is our decision tree. This is also not very readable. So we can also pick the explorative visualization here. And as before, it of course now these diagnostics are all Boolean attributes, so it only splits on true or false. So you don't have splits based on smaller than, bigger than check, but it's just true or false. But then everything else is as before. Right, so let's carry on. Last one asks us to build a decision tree predicting the elapsed time of cases based on just one predictor variable, the number of executions for each case of the antibiotics event or activity. And the discretization is the same. So in order to do this, we need to change it a little bit. So I want to see the helicopter once again. There it is. So if we go on attributes and we deselect this, right? Yeah, takes a bit to deselect these ones. So we want the number of executions of a certain activity per each case. These are selected and should not be. So the way we do that is that we can go on control flow perspective here, which gives you some support for targets and attributes derived from the control flow perspective. And there is also the number of execution of activities per case. So we're going to click on this number of execution of antibiotics, and we are interested in the elapsed time, and we can create our augmented event log, right? And we have just one split. We are, after all, basing our prediction on one feature over 2 pins. But if the execution of antibiotics is higher than 0, then predict the high bin, so the longer duration. If it's equal to 0, essentially, it predicts the shorter elapsed time. So it's basically going to say, I can see that if antibiotics are administered at least once, the case is going to be long, based on our bins, which are these ones. Here you can see a summary of the bins, the starting value, the end value for a bin, and also the name, the label, which is reported in the tree. And the label is just the interval written in an extended form. And this is R3 is very simple, but is a good example of using the number of execution of a certain activity as a descriptive feature. If we go to summary, we can see that for some classes, the prediction is very accurate, but that's also just because we have just 2 bins, right? So let's carry on. And now exercise 2 asks us to construct a decision tree to this time predict the next activity with using all activities or all the fields that we saw before as descriptor variables. And the way we do that is that we go here and we deselect these. We select the attributes we had before this, and then we go on control flow. We can close this number of execution activities thing here, and we select the next activity. So we're going to predict the next activity based on these features here that we have in our log. If I create, it prompts me to decide what is this, let's say, the set of next activities I'm interested in to create the target, but I'm interested in all of these. So I will just say yes. It creates a decision tree, takes a bit of time. And we see that as before, we have a very, very involved tree. Wait, see, I was about to fall for this. I did not check if the dependent attribute was the correct one, and it is not. I need to select the next activity here, right? And then update the decision tree. And then we wait. And then we get our decision tree. As you can see, there is a decision point, which is very complex here. This is more suited to the explorative visualization here, which we can see that now the target is not a value, but it is an activity in the process. So if I'm here and this feature here is false, I predicted that next activity will be leukocytes, which is possibly an exam of the count of leukocytes, I guess. So it works very similarly, but now our target is an activity of the event log. And so this is a decision tree on, it has a very, process mining flavor to it, because we are predicting control flow features, which are very much associated with the domain of process sciences, using well, not really a machine learning approach here, because it's just a decision tree, using statistics, right? Yeah, I know that. So statisticians get very angry when you say that things that are classical in statistics are machine learning. So we're going to go with statistics here. Okay, so what's the next one? Okay, it asks us to build a similar tree for the next activity with all diagnostics as independent attributes or as a prediction attributes. So let's switch back to the helicopter. Looks like a helicopter, right? We deselect these. We pick the next activity and we pick the diagnostics, which are these. Yes. Oh, okay. Our tree has disappeared. So there is just one box here. The algorithm decided not to split on anything and just say, yeah, next activity is leukocytes, because this is because, of course, of the ProM attribute here. If we don't prune the tree at all, and we update the decision tree, we should see something slightly more sensible. And we have it, yes. So this is a decision tree, which, as before, predicts the next activity using the diagnostics information as independent attributes. And it predicts a control flow feature of our process using the data it has at its disposal. Right, so I think this covers quite a bit of the use of this plugin and how to build decision trees. Are there any questions on this prediction in general, how to build a decision tree? I see that there have been quite some discussions in the chat, but I think they are more pertinent to the assignment and other, let's say, logistical things, but not the instructions. So are there any questions on the topic of the instruction or yeah, prediction in general, operational support in general? Okay, so if we have no questions, let's switch back to the slides, and I think you can see my slides. Because the last thing I want to talk to you about is this. So lecture has been on refined process mining. It has touched on a huge number of topics. Bill mentioned a lot of things like operational support, prediction, recommendation, but other things like cartography, log repair, filling in missing data, anomalies detection also on streaming data, and basically he gave a map of all process mining. And so I thought that it would be more useful to you, rather than for me to talk, like to pick one or two arbitrary topics from that list. It's more useful maybe if I talk a little bit about how to access information on a specific topic in process mining you might be interested in, or how to mine process mining if you like. So the way to do that is to always refer to research, and research that hopefully is recent. Of course, in computer science, you need to be very careful, because if you see a paper which looks interesting but is like 4 or 5 or 6 years old, might very well be that it's slightly obsolete, because in the meantime someone improved that approach and already a new version came out. So you need to look at very recent research, and I wanted to give you some pointers to do that. And the first one, so some of these you know very well, but I wanted to include them in the slide anyway. The first is Google Scholar, right? So Google has decided to build this search engine, which uses a tiny fraction of the potential for search that Google has. It has, as you can see, like I included the search interface here, and on the left hand side you can see a very few filtering settings that you have here. But it is a nice starting place to find new research, new papers. This indices the authors, the title, the venue, the abstract, etc. You can see the number of citation and serve the papers that cited a certain paper you're looking at. And also you have profile pages where you can access all the research of a specific scientist. And so this is often the starting point if you're looking for research on a topic. It can be process mining, can be something else. You also have Archive. So Archive, differently from Google Scholar, Archive is a site that hosts preprints. So it hosts open access copies of papers, some of which have been already published, so they are trustworthy because they have been checked by other scientists. Some others, they are called preprints, are not published yet, so you need to be careful. And archive, they spelled archive like this to be cooler, I guess, but it's pronounced archive. Hosted by Cornell University. And then the third website where you can get essentially free papers is ResearchGate, which is similar to archive. So it's a preprint archive. This also has a social component. You can add contacts, you can comment other people's stuff, etc. But it is essentially the same thing. There are others. These are not just, so Archive and ResearchGate are not the only two archives of preprints, but these are the hosts the vast majority of computer science papers. So the other archives are usually dedicated to other sciences. There is, for example, bioarchive, which focuses on papers from biology and medicine. So I did not include it here, but be aware that there are others. Also beyond surfing these websites, there are other ways you can learn more specific informations. And the best way to do that is to keep an eye out for some of the conferences which are the typical outlet for process mining research. So here they are listed in decreasing order or relevance for process mining. So there is the International Conference of Process Mining, ICPM, which has an official website at that link. Was organized, this started out in 2019. We organized it here in Aachen, and now it is a conference completely dedicated to process mining, so only process mining papers there. Then there is BPM, the International Conference of Business Process Management, which has some more history behind it. I think this year is the 16th or 17th, something like that. I did not include an official website because it changes based on the year. So every year they register a new website, but you can just Google the name and you find out. And then KAISE, the Conference on Advanced Information Systems Engineering, also has, you find quite a lot of process mining papers there. So ICPM only process mining, BPM mostly process mining, and KAISE a good deal of interesting papers in process mining. Also does not have a fixed website, but every year it changes. So you need to Google this. So if you look for process mining research, which is very recent, and you want to look at really the state of the art of things, you can just check out the website of the last edition of these conferences, and there you go to the program page. These have a program page, and you see the title of papers. Those are very recent papers in process mining. So that's also how you keep yourself up to date with the science that is published. And the very last thing is that these conferences, specifically ICPM and BPM, also have workshops, which are smaller events, which are co-located, so are organized with the conference. Usually they span one day. And the nice thing about workshops is that they focus on a very specific, quite narrow line of research. So if you are interested, for example, in, I don't know, in process mining on healthcare, there is a workshop, so a research event completely dedicated to healthcare. And I see it here. And if I switch to my browser, I think I have it open. Yeah, so these are the workshops for ICPM this year. There's one on process querying, one on process mining for healthcare. There is one dedicated on streaming data, streaming events, and doing process mining on streams. There is one on behavioral analytics, and one dedicated to trust, privacy, and security in process analytics, right? And there is also this last one is on machine learning merged with process mining. And all of these are extremely interesting, and even more if you are specifically interested, of course, in that topic. And for BPM this year, there is one on artificial intelligence with business process management, merged with business process management. business process intelligence workshop, which is a sort of selected topics on process analytics. And there are many more. It is on declarative processes and analysis of the declarative process data, social and human aspects of business process management, and one for the governance, and also a security and privacy ones. As you can see, you have a whole host of topics, and of all these topics, you can find out the very latest research looking at the program of these workshops, also others on business processes and the Internet of Things. This is something they did this year for describing problems interesting to solve in the near future. If you are interested in any of these specific topics, I encourage you to go on these pages. Now, these refer to this year, but you can also check out the ones for previous years. And then you have a panoramic on the very, very latest, the most advanced research on very specific narrow topics, right? So this concludes our instruction for today. I will stop the recording now.